In this video, we are going to learn how to perform the prime factorization of a given number. First, we're going to see how we do it manually, and then we're going to translate that process into an algorithm that can be translated to a program. Right? So the question states, we need to print the result of the prime factorization of a number. For example, if the user enters 18, then the program must display 2, 3, or 3, which are the prime factors of 18. Right? So let's begin this through an example. So here we have a number 666, and we're going to find the prime factors of this number. So at the very beginning, we always begin with 2 as the factor. We check if 2 is the factor. Now why 2? Because 2 is the least positive prime number, right? That is the reason why we begin with the number 2. Now as 2 divides 666, therefore we can conclude that 2 is a factor of this number, and hence we continue the division process. Now we divide 666 with 2 and we get the quotient 3, 3, 3. Alright. Now our current factor is 2, but you see 2 is not a factor of 333 as it does not completely divide the number 333. Hence what we do is we increment the current factor by 1. And we get 3. Now 3 is a factor of 333, therefore we divide the number and write the quotient. Moreover, 111 is still divisible by 3. You see the summation of the digits of this number is 3, and that is divisible by 3, hence 3 divides 111. And we get 9, that's 2, 21, 37. Okay. Now 3 does not divide 37. So we go on to the next factor, 4. Now 4 does not divide 37. Now if you continue this process, we will see that no other number divides 37 except for 37 itself. Therefore, we write 37 here, and after division we get 1. Now when we get the quotient as 1, we stop because our job is done. And the results are these. So 2, 3, 3 and 37 are the prime factors of 666. So let's see. So this is the process that we have been doing since the very uh, primary days of our schools, right? So everyone knows this process. Now let's do one thing. Let's translate this into a suitable algorithm, right? So I'm going to demonstrate the algorithm through the help of the dry run, and then we're going to move on to the programs, right? So the first thing that we want to require is the number that we want to prime factorize. So that's going to be stored in the variable num. Now the next variable would be for storing the factor, the current factor, and I'm renaming it factor. Now this is a condition. The condition is factor is divisible by num. Is divisible by. All right. So let's see. Let's use a different color. Let's use this. So let's begin this process from the very beginning, from 666, right? So this is our initial number, and the initial factor is 2. Now, does 2 completely divide 666? Well, it does, right? So the answer is yes, or in computer terms, it would have been true. Therefore, we divide num by 2 and we save the quotient in num, and the quotient is 333. Now imagine, what would be the expression for storing the quotient of num divided by factor into num? So if you think carefully, you're going to see that this is the corresponding expression for doing just that. Okay. Now the next step, now the current factor hasn't changed yet, right? It's still 2. Now actually I've written it wrong. Num is divisible by factor. Num is divisible by factor. Really sorry, I wrote it wrong. Let's change it right now. So in this situation, you see num is no longer divisible by factor, right? So therefore, and under this column, I'm going to write false. Now, because the current factor no longer divides num, what we're going to do is we will increment the factor by 1. We're going to move on to the next factor. The number is still 333. Now the current factor divides the number, hence under this column we're going to write true, and we're going to divide num by factor. And that's going to yield 111. So this is the expression that was employed. Now the current number is 3. Now 3 still divides 111. Therefore, the result is true, and we divide num by factor and we get 37. All right. Now, the current factor no longer divides num. In this column, we're going to write false, right? And because I'm running out of space, I'm going to move this up. And we're going to move on to the next factor. And we see 4 also does not divide 37. Therefore, we move on to the next factor. Because writing till 37 is a little cumbersome, so I'm going to skip a few steps and we're going to come directly to 37, because we know that 37 is a prime number and it is the only number, and 37 can only be divided by itself. So false. So we move on to the next few factors, and then when we come to 37, 37 divides 37, hence under this column we write true, and we divide num by factor to yield 1. Right? And the current factor is still 37. And because the num is 1 right now, therefore we stop. Now there's one thing that I missed, is the output column. Now what do we write in the output column? Now if the factor divides num, then we display that factor as output. So in this particular row, we see that 2 divides 666, hence we divide num by factor and we display the factor as well. In this row it's false, but in this row that's true. Therefore, we display the factor. In this row it's true, therefore we display the factor again. Now, coming below, in this row, the result is true, hence we display the factor. I missed this, but I'll cover this in the next example that we have. Okay, so in this example, we have the number 126, right? So you could do one thing, you could try to complete the Dryden columns by yourself and see if you have understood what explained in the previous slide. The heading is going to be num, it's going to be factor, num, factor divides 1 minute. Okay. Factor divides num. I've just changed a few words so that it's small, right? Let us first complete our working, and then we're going to move on to our Dryden. So we always begin with the number 2. 2 divides 126, hence we get a quotient of 63. Now 2 no longer divides 63, so we move on to the next factor, and that's 3. And 3 divides 63, therefore, and we get the quotient as 2 and 1. Now 3 still divides 21, hence we get a quotient of 7. Now 3 no longer divides 7, so we move on to the next factor, which is 4. 4 does not divide 7, hence we move on to the next factor, that's 5. 5 does not divide 7, so we move on to 6, and then to 7. And 7 divides 7, hence we divide and get a quotient of 1. Because you have obtained 1 here, therefore we stop. Alright. So let's see how that is going to work out in this Dryden. Alright, so we start with the initial number, and that was 126, and the initial factor was 2. Now factor divides num, right? It's true. Therefore, we display the factor 2 and we divide num by factor to obtain 63. Now the current factor is still 2, but 2 does not divide num, Hence, in this column we write false and we increment factor by 1 to obtain 3. Now we see current factor completely divides num. Therefore, in this column we write true. We print out the current factor and we divide num by factor to obtain 21. Now, the current factor still divides num. Therefore, we write the current factor here and then we divide num by factor to obtain 7. Alright. Now 3 no longer divides 7. Hence, we write false and we increment 3 by 4 by 1. I'm really sorry. 4 still does not completely divide 7. Therefore, we increment the factor yet again. 5 does not divide 7. Therefore, we increment the factor yet again. 6 does not divide 7. Hence, we increment the factor again. You see, I'm only printing out the factor when the factor completely divides num, when this particular column is true. In all other situations, I'm just incrementing the value of factor. Understand this algorithm because this is what is going to help us in writing our code. Right? Now, the current factor divides num. Therefore, we display the current factor and we divide the num by factor to get 1. Now, because num has become 1 in this case, therefore, we stop. And this is our output. Now, it might seem to you that every time I'm taking an example in which the number is an even number, therefore, while starting with 2 as the factor, we are getting the first row as true. But that may not be the case. So in this particular problem where the number is 105, 2 is no longer a valid factor. So even if we start with 2, let's use this color for now. Even if we start with 2, we cannot use 2 because 2 does not divide 105. Hence, we move on to the next factor, that's 3, and 3 divides 105 because the summation of these digits are 6. So the quotient would be 3 and it would be 5, right? Now, 3 no longer divides 35, so we move on to the next factor, which is 4. 4 does not divide 35, so we move on to the next factor, which is 5. Now, 5 divides 35 and we get a quotient of 7. Now, 5 does not divide 7, so we move on to the next factor, that's 6. 6 does not divide 7, we move on to the next factor, that's 7. 7 divides 7, and we get a quotient of 1, and we stop at this point because the quotient has become 1. Right? Let's see how that would play out in the dry run. So, our columns would be num, it would be factor, and it would be factor divides num, and let's use a different color. Okay, so the initial number is 105 and we always begin with a factor of 2. Now 2 does not divide num, therefore under this column I write false and we increment factor by 1. You see there's no output for this row. Now 3 divides num, therefore we write true here. We output the current value of factor and we divide num by factor to obtain 35. Right? Now 3 no longer divides 35. Therefore, we increment the value of factor by 1. Now 4 does not divide 35. Therefore, we increment the value of factor by 1 to obtain 5. Now 5 divides 35. So we display the value of the factor and we divide num by factor to get 7. Alright. So 5 does not divide num at this point, right? So it's false. So we increment the factor by 1 to obtain 6. 6 does not divide num. Therefore, we increment the value of factor by 1 to obtain 7. Now 7 divides num, right? Therefore, we write true here. We display the current value of factor and we divide num by factor to obtain 1. And because we have obtained 1, we stop. Right? So here is our output. Now, there might be some of you who agree with this algorithm and are ready to write a program, right? So you could very well pause this video right now and have a go at it, because I've explained the algorithm through the help of a Triton. Though I have not explicitly written the algorithm in the form of a pseudocode, but I think you get the point about how the algorithm works, right? But there might be some of you who are screaming at the screen right now that how am I ensuring that the factors that I'm displaying are prime? You're completely right. You're completely right. I'm not ensuring that. I'm not checking whether these factors are prime or not before displaying them. But that is not required. Now, why it is? To explain this, let me move on to a new slide, because this slide has been filled with numbers and write-ins. All right, let's create a board here. Okay, this. All right. You see, whenever we choose 2 as our factor, right, it gets rid of all the multiples of 2. For example, 2, 4, 6, 8, and all the even numbers, right? Then what we do? We move on to our next factor, which is 3. Now, if you divide the number by 3, dividing it with 3 takes care of all the multiples of 3, such as 3, 6, uh, 9, then 12, etc. Right? And you see, 6 has already been taken care of by 2. Therefore, we didn't. Therefore, 3 does not divide 6 here. 12 has already been taken care of by 2. Therefore, 3 does not need to divide 12. It will only divide those multiples, take care of those multiples which have not been taken care by 2. Now, the next factor that we move on to is 4. But you see, if 4 existed as a factor of the initial number, it had already been taken care of by 2, right? So there will be no situation in which we are going to use 4 as a factor, because it has already been taken care of by 2. Now next, we move on to 5, and 5 takes care of all its multiples, such as 5, 10, 20, 15, 25, 30, etc. Right? Then we move on to 6. You see, all the factors or all the multiples of 6 have been taken care of by 2, right? Even if it has not been taken care of by 2, it will be taken care of by 3. So this is the reason why this particular algorithm works, and here we need not check uh, if the factors are prime or not. That's a redundant checking, because this method follows that if we begin with 2 as our initial starting factor, then it will take care of all the other non-prime multiples of 2, right? If you need to read up on this method in great detail, which would provide you with more explanation, you could look up this particular thing in Google: sieve of Eratos things. Let's Google it, right? Google.com, sieve of Eratos things. So this particular algorithm talks of how we can generate primes uh, very quickly, right? So you could read up on this to understand why uh, we do not further need to check and to ensure whether these factors are prime or not. Following this algorithm, the factors that we obtain will be prime. You take any number as example, you try to prove me wrong, it will not. And if you need a concrete reason as to why, you need to better understand the reason behind this, you could look up Siva Vidato's themes algorithm, right? But because this is not under the scope of this video, I'm going to skip this. You're free to read up on it on your own time. All right. So we have discussed this algorithm in great detail. Now let's move on to the programming aspect of this. All right. Let's create a new class and let the name of the class be prime factorization, but we put gibberish here. I mean, come on, open up. Yeah, finally. Okay. So import java.util.scan plus factorization. Alright. Now I am in the habit of creating a function to solve stuff because it helps me think clearly when we are dealing with larger sets of problems, right? So I'm going to create a function here, but you are free to write the code present inside of the function in main method directly. It's up to you, but I prefer writing a function. All right, print prime factors. It's going to take in a num as input. Okay. All right. So what are we doing? So we are taking the numbers input in this particular variable, right? So next, we need to do something repetitively, right? So for this, we need a loop, and I'm going to use a while loop at this point. Now, why while loop? Because we do not know how many times the loop has to run, so as to find out all the factors of num. Therefore, because it depends on the condition, we're going to use the while loop. For the time being, I'm leaving the condition, right? Condition will seem more apparent when I write the body of this while loop. Now, the first thing that we do is, and in fact, we need a few variables up top. I really forgot. So we need a variable called factor, and the initial factor that we have is 2. All right. So first order of business, what we do? We always check if factor divides num. So we need to check if num is divisible by factor. That's the other way of saying it. So for doing so, we could check whether the remainder of factor dividing num is 0 or not. So num mod factor equals 0. If it is, we can safely say that factor divides num, and therefore what do? We first display the factor as output, and I'm going to use system.out.print at this point so as to display it using comma separated. So comma plus and factor, right? And then I need to reset the variable num to the quotient of this division operation. So num equals num by factor. Now, what if the factor does not divide num? Well, in that case, what we do is we increment factor by 1. You see, in this at this point, 2 did not was 2 was is does not divide num. Therefore, we incremented the value of 2, right, by 1. So factor equals factor plus 1, or as a shortcut, you could always use factor plus plus. All right. How long should this method continue? You see, we used to stop doing this division operation when the value of num became 1. We knew for sure when the value of num becomes 1, we have found out all the prime factors of this number, right? So that is what is going to be our terminating or the test condition here. So num not equal to 1. This loop will continue to run until the value of num becomes 1. And that's it. Now, why is this method void? This method is void because it just prints out the factors. It does not perform any calculation. It does not compute a value. It just displays the factors on the screen. That is the reason why the method has a return type of void. Moreover, it does not return anything, return any value. Therefore, the return type is void. So let's create the public static void method now. String args. So here, firstly, we're going to create an object of the scanner class. And then we will public static. And then we're going to create an object of this class, prime factorization. We'll do new factorization terminator. And then we're going to take the number whose prime factors need to be displayed as input. So system.out.print enter number. int num equal to sc.nextInt. All right, and then we're simply going to call this particular function using the object that we created. But before that, it's better to display some message. System.out.println prime factorization of num obtained obj dot print prime factors. So whenever you encounter a void method, we always call a void method using this particular line. We do not assign its value to a variable because there's no value to be assigned. This function does not return a value. All right, let's compile and let's run this. Let's run this with our example. So the first example that we're going to consider is 666. Let's run this with 666 and the prime factorization obtained 23337. Let's see. Yeah, it tallies up with our output. Okay, let's run this program on 126. That's 126 and it obtained 2337. Is it equal to this output? And yes, this. The next number that we have is 105. Let's run this program on 105 as well. 105, obtain 3, 5, and 7, and that's 3, 5, and 7. And to give justice to this question, let's enter 18 as well. 2, 3, and 3, right? So this was prime factorization of a number in Java. I hope you understood this video. I hope you understood this explanation, and hope to see you in the next one. Bye for now.